Your time.
I'll try not to hang myself with a cable.
All right.
Cool. So this is joint work I did with Howard Mansell at Blue Mountain Capital. And it's sort of targeting some of the problems that Blue Mountain Capital has. I'm the person who wrote some of the libraries, and Howard is the person who sort of helped to make sure that it's actually doing what they need. So I can't tell you very much about what Blue Mountain Capital is doing, but they're basically doing time series analytics to figure out some signals, and based on the signals, humans make a decision whether about their trading strategies and so on. So the idea here is what they're basically doing is that they're looking at lots of time series data or other sources of data, and they're doing some. They have people who are writing code to come up with some clever algorithms or to calculate various statistics. And the code base at Blue Mountain is partly in C# and then partly in F#. And there's people using sort of the libraries in both C# and F# depending on who prefers what. Lots of the sort of people doing the actual analytics started using F# and are quite happy with it. And this is what I'll be talking about is mainly libraries that sort of we've built for them to make their work easier. So there's two parts to this. We have a library called DDLE, which we figured is an acronym for .NET Exploratory Data Library, and the additional E's are for Extreme Excellence. And then there's R Provider. So what do these two libraries do? DDLE is a library where you load your time series data, and you can do basically all the boring things that you have to do when you get any data. So you have to transform it to the right format, do data cleanup because you'll have sort of data coming from different sources that are not aligned, and you have to align it before you can do any calculations. And then you can pass the nicely cleaned up prepared data to some tools, other libraries to do statistics or visualization. So the DDLE library is sort of the fundamental piece that puts everything together, because that's where you go when you have the data before you can pass it somewhere else. And one of these somewhere else is what the R-type provider is doing. And the idea here is there's no way we could ever re-implement all the 5,000 packages, tested statistics packages that are there in the R ecosystem or visualization tools. So we need to give the people easy way to call into R. So I'll start with a quick demo, and I'll show you what the R provider actually does. So what I have here, oh, I can even make this bigger. The nice thing about F# is that you can always make it bigger, it will still fit. So what I have here is sort of a typical scenario. I have some setup, which I'll explain later, but what this basically does is that I'm reading some data from a CSV file on my disk, and then inside here I can get prices. So this is using other F# features like type providers, where if I look at the rows in my data set, it will actually give me types, properties for all the columns in my data set. So this is representing different currencies. And I can get a list, and this is a list which lives in the F# interactive window, and it's just an F# list. Now let me copy a bit more code here. This is, again, nothing really interesting. It's just calculating the difference between consecutive days so that I can show you something more real. And if I now want to do some statistics or visualization, there's a bunch of tools I could use in F#, and they would be fine for many things. But if I want to do a bit more, then I'm going to use the R-type provider here. So the first thing you can see when I do dot, it will actually give me a list with all the R packages. So the type provider mechanism here is used to import the R packages into the F# world. And I can open something like graphics to do visualization, or I can open ggplot2, which is a really nice visualization library. And when I do R dot, it again exposes all the R functions. Now the interesting thing, and I'll talk about this a bit more, is what can we actually infer from R? But let me call it first. I think I need to run this. And then this will, somewhere on my desktop, open an actual R window. So this is just calling into the R runtime, but I can control the whole thing from F#, and I can get the values between R and F#. Or I can create a histogram with the differences, and again, this just pops up an R window where I can see the histogram. Or if I want to do something a bit shinier, I can use the ggplot library, and this is going to create a chart showing the price as points, or the exchange rate as points, together with smoothing. So there's sort of interpolation behind the scenes done by the R charting library. All right, so what's interesting here? There's one interesting thing is that we are using the type provider mechanism, which is basically a way to inject your types into the F# language based on whatever you can find in the environment. The way it works is that there's basically a plugin into the compiler that will look at all the packages. It will call the R runtime, it will get all the packages, it will get all the function names, and this is where sort of the situation starts being interesting, because R isn't really sort of statically typed. You can use the reflection capabilities to get all the packages and all the functions. You can sort of ask it what are the parameters of the function, and when the function actually declares this, it will give you the parameter list. But sometimes R functions can take arbitrary parameters, and you can't really sort of infer that. So what you can see up there is that r.parse is one sample function, which is imported from the base, and all the arguments are optional. F# supports that, and it works nicely. All of them are inferred as objects because we just automatically can't infer more precise information. And there's also another overload that will take named parameters. So you could see that, for example, here I'm just giving it the named parameters, but if I wanted to specify something else, I would have to create the dictionary, and the code would be a bit uglier. So it works pretty nicely. There's a few things that would make it nicer, which I think is an interesting sort of thing for people working on programming languages. For example, the first example there, sometimes in R, you really need to give it sort of arbitrarily named parameters. I can create a data frame and just use column names as the parameters. So here, it would be kind of helpful if I could just dynamically specify the argument names, even if, or have some way of saying, well, this function takes parameters and you can give it anything. So that's sort of bridging the rigid, statically typed world in F#, which works really nicely when your outside world is nice, but if your outside world is messy, then having some sort of escape route is interesting. The other interesting thing about R is that if you say plot day's prices, it will give you a chart where the labels are annotated with the text days and prices, even though days and prices are just variables. So in R, you have the more sort of power in looking at the expressions, and that's another thing that we would really find useful to have in F#, have some way of actually looking at the expression. And the F# language is actually open source. They're accepting pull requests, and one of the things we are working on is adding these two things to the F# language to sort of make it better for this application. But there's other interesting uses of both of the features. Now the other library, Deedle. So at Blue Mountain, they actually already had time series and data frame manipulation library. So for them, this is the third iteration. And because I'm partly responsible for it, I can't really comment how people like it objectively, but I think generally the perception has been pretty good. It is written in F#, but it's designed so that it works really nicely from both F# and C#. So it's sort of really deeply integrated, and it exposes both the nice, or for me, the nice functional interface, which I'll be showing, but there's sort of equal, you can do all the things in a more object-oriented style as well. One nice thing here is well documented, it's open source, so assuming my internet connection works, I can even show you the documentation here. There's lots of interesting things about the documentation, including the fact that this is actually all, when we build a new version, the documentation is type-checked, and it actually runs the documentation, and if there's anything that fails in your documentation, you will not release a new version. And all the identifiers here have nice JavaScript tooltips. So there's lots of sort of effort into making this really nice open source project that others can contribute to, and there have been quite a few people who have already added features to it or fixed some naughty bugs that we left in the library. So there's two concepts that you need. One is the series, which is basically a mapping from keys to values, and the keys are often dates, so you're mapping time to some value, and in series you always have the same type of values, so the value is always a float. Frame is basically a two-dimensional table where we have some row key and column key, and again the rows are often sort of dates, but the columns can be of different types. So in F# we are actually representing this as a heterogeneous frame where you are, so it's not fully statically checked in a sense, because the columns can have different types and you can also mutate columns. So let me show you a quick demo, and I'm going to read data from the same CSV file I had before. I'll have to load everything, and now you can see the frame here, and my row key, that's all you can see there as a date. My columns are different currencies, and the values in this one are actually always floats. So I can get indicator for one currency, and that gives me a series where I statically know that this is a float. Or I can do some interesting calculations. So I can do shift the series by 1 to calculate the differences between days, which is what I was doing previously in the sort of list processing version of the code. And then I can do calculations like calculate the daily returns over the whole series and get that as a percentage, which I think is probably done wrong because my bracket is elsewhere. So now I've got some calculation, and I could do mean. So you can do some sort of interesting processing, or you can also do the whole thing on an entire frame. So this is more fun example where we calculate the daily returns for every single currency, and I can even sort it and see that for the particular period, the worst way of investing was getting bitcoins. So there's lots of interesting sort of questions here. For example, do I stay mutable or immutable? Well, in the D library, we actually have very mutable internals because it's all using unboxed.NET arrays, although we only mutate them when we are creating the data structures. And so the next level, the data storage, is actually using immutable vectors, which means we can easily share them and get all the nice functional properties. But at the sort of top level, the users who work with this interactively, they actually have a little bit of mutation, or they're allowed to add new columns to a frame, because when you're building up data structures interactively, that's really powerful programming pattern. There's again, sort of, where do we pick the right line between static typing and dynamic typing? So in series, you know statically both the type of keys, like the date and the values, the floats. But in data frames, we only track the types of rows and columns, the keys. So row keys could be date time, column key could be a string, but we are not tracking what the values are. And so every column can be heterogeneous, which again sort of is a compromise, and we pick this because in F# that gives you code that's fairly readable. You can have bugs in your code, but that actually doesn't happen that often in practice, and all the sort of type-safe ways of doing that make the code much uglier. So there's the pragmatic choice here again, and there's sort of interesting research question with things like row types. How can you represent that better and still keep the code readable? So if I'm correct, I should be probably wrapping up.
Yeah, we have 5 minutes with questions. So.
All right. So I'll just jump to the end, and maybe before I do that, I'll run this last version of the sample, because this will take a little bit of time. But the idea here is, the bigger picture is the D library with the time series and data frames actually gives you sort of nice foundation around which you can build other things. So this is one experimental project that's building around it, and it lets you write your documentation as markdown comments, or maybe common markdown, or how they call it. And it will generate a nice report with like embedded data frames and embedded R output and so on. So the interesting thing is, once you have the core data frame and series library, you can actually integrate a lot of interesting things around that. And I think that the interesting experience with the design here was finding the sweet spot between the full safety and the ease of use. Thanks.
Do you have any questions?
Or do people want to see some more pretty charts or code?
You have a couple minutes to go.
No, I think I'll be happy to answer some questions if there are some. Yes?
How large are those libraries in terms of lines of code? How difficult it was to implement?
So the core DDL library, that was me and 2 other people, sort of me working on it full-time, 2 other people part-time and on the design. And we built most of it in 3 months. The R-type provider, that's actually even simpler. There's more work on, that one greatly benefited from the fact that there already was a library for sort of calling R from .NET. So just wrapping that in the nice F# API wasn't that hard. The DDL library is more work, because that's actually sort of thinking about the design and implementing something. But yeah, I find it very pleasant.
I do have a question about the alignment primitives that you have.
Do you want the mic?
I'll just speak really loudly. Sorry, which validates me and my rooms. As to the how complicated do those alignment primitives get that you're working with?
Mm-hmm. Yeah, so the question was about the complexity of the different alignment primitives. So we do have quite a few of these. You can, if you have two different time series that don't quite match, you have the sort of fairly standard database options like doing inner join, where you find the matching keys, or the outer join, or left and right joins. But that's really not what you want very often, because you might have that, like one series happens a millisecond later. So when you're doing left or right join, you have the option to say, find the next available value in the other series. So if I have like one data and another data source which is 1 hour later, I can say, well, find me the previous value or find me the next value. Then there's a bunch of sort of sampling primitives where I can say, generate time series where I'll basically get chunks of data for every hour, and it's up to me to decide how I want to aggregate it or pick the last one, pick the first one. So I think that's roughly the overview, but there's a lot more on the documentation website. So, it's not the right one, but this is not the right one again. But it's there. I think if you look at time series somewhere, there's lots of things.
That actually would be quite useful to me. Thank you.
Yeah.
All right.
All right.
We have a 20-minute break, and then we pick up.